This is the video tutorial for pages 8 and 9 in our Unit 2 homework packet. Okay, we're balancing nuclear equations here. So we can treat this symbol, which stands for yields. We're saying this 152.63 EU yields an alpha particle plus blank, or equals. So we can pull this as two separate kind of equations, real simple algebra. If you don't like that word, then just real simple fill in the blank. Okay, but our top is 152 equals 4 plus blank. I won't say x in case that freaks you out. The bottom is 63 equals 2 plus blank. Okay, so if I'm solving for this blank, okay, 152 breaks up into 4 plus something else. I'm going to subtract 4 from both sides. Minus 4 is 148 equals this. Okay, so 4 plus 148 is 152. So that's going to be my top number here, 148, because 148 plus 4 equals 152. Okay, then on the bottom I have 63, and it's going to react in fission to break apart, break up into something too big, plus what else? That one would have to be 61 big, because 2 plus 61 equals 63. So we go like that. And then we need to figure out what element is 61. Okay, we've got that right here. 61 is PM, promethium. Big P, little m. PM. And you'll notice up at the top, that's an example of alpha decay. You have an alpha particle right here, breaking off. So your mass comes down by 4, and your atomic comes down by 2. Number 6 is beta decay, and you beta believe that's the weird one. Okay, a beta particle is when a neutron turns into a proton, which gets just a little bit weird. I'm going to switch colors so that we can see this more clearly. 138 on top equals blank plus 0. Okay, well, that one's pretty easy. 138. The top number has to be 138. On the bottom, it's 53 equals blank plus negative 1. Okay, so that means 53 plus negative 1. So the opposite of plus negative 1 is just plus 1. Okay, if you subtract a negative, you're adding a positive. So what I'm saying is whatever this is, take away 1 equals 53. So that's 54. 54, take away 1 equals 53. Like that. So number 54 on our periodic table is xenon, Xe. Okay, and I'm going to say this again. You beta believe this is the weird one, beta decay, because a neutron turns into a proton. So my total number of protons and neutrons doesn't change. But now I have a new proton, so my number goes up by 1. I know, it's weird. BH272 is going to turn into BH271 plus blank. So let's just look at our top numbers. 272 equals 271 plus, okay, something plus 271 equals 272. So that's 1. 1 plus this equals that. So my top number is 1. 107 on bottom equals 107. Yeah, plus nothing. It has to be 0. It can't be anything else. Okay, if my bottom number is 0, then my symbol is going to be a neutron. Neutron has a mass of 1 but is not a proton, no protons. So this was an alpha particle, alpha decay. This is a beta particle, so beta decay. And this one had to be a neutron. That's what was missing. Number 9 is a wonderful question. It's a mean question because I gave you 2 blanks. Okay, so nitrogen 15 breaks up into blank plus blank. it tells you it undergoes alpha decay. So you know one of these blanks has to be an alpha particle. That is not something you have to memorize. Alpha particle will always be given to you on the test. In fact, it will look like this on your periodic table. Okay, it will say nuclear on your test periodic table. It'll show you what an alpha particle is. So I know one of those blanks is 4,2He. And since we're adding, doesn't matter if that's in front or in back. Go like that. Okay, now this problem looks like the top. So you have that extra little step of filling in one of the blanks. But I'm going to say 15 equals on top 4 plus something. On bottom, 7 equals 2 plus something. Okay. So I had 15 Legos, and then one of my sons smashed it, classic, and 4 of them broke off. So that leaves me with something that's 11 Legos big now, and fighting children probably, because that's my life. Facts. Okay, so my top number is going to be 11. 11 plus 4 equals 15. True story. Great. I have something that's 7 big, and I break it, 2 come off. So my other thing is going to be 5 big. 2 plus 5 equals 7. True story. All right, then we need to figure out what symbol goes with number 5, and that's boron right here. So capital B will be my symbol. People freak out with the algebra sometimes, and their brains just say, no, no, no. Okay, well then think about it as Lego tower that gets smashed. That's okay if you don't like solving for the algebra. Alpha, beta, gamma. We made a nuclear foldable in class. If you were absent, there are PowerPoint slides for it on Canvas that you need to check because it's important stuff to memorize about them. I think we actually did it last class. But alpha particle, beta particle, or gamma. So it says exposure would result in no symptoms of radiation poisoning, which means it's kind of the safest one to be around, and that's the biggest one to be around, alpha particles. Now that's external exposure. If you're ingesting alpha particles, you've got a whole series of problems. If you're breathing them in or eating something contaminated with it or whatever, you got problems. But on your skin, alpha particles are too big. You're going to get blocked by paper, your skin, your clothes. Number 15 says exposure equals widespread damage and severe radiation poisoning. Now alpha is going to be pretty safe. Beta particles, external exposure, are dangerous. Gamma, though, if we're talking about widespread damage and severe radiation, that's going to be our most dangerous one. Gamma. That's what you are usually thinking of when you talk about most dangerous radiation, the Hulk, Bruce Banner type of thing. That's gamma radiation. Used by Rutherford in the gold foil experiment, he used alpha particles. Rutherford Rollo, and the least penetrating. Okay, penetrating means like getting into your cells and your DNA. The least able to get in and mess up your DNA would be alpha again. They're the safest or the least penetrating. Okay, on our other side, this is really similar to the first few I showed you, where you're going to balance your equation, but we're also asking you to circle the radioactive particle and name it. So you're, for every problem, going to say alpha, beta, or neutron. So for this one, let's say alpha. Alpha, this one didn't give you one. So whatever your answer is going to be one of those 3. Okay, alpha. Number 5, I didn't give you one either. So let's look at that together. Okay, 93 breaks up into 92 plus something. So what added to 92 will equal 93? That's got to be 1. 1 plus 92 equals 93. So immediately I know that's my answer. Because if there's a 1 on top, it's got to be neutron. I'm going to be smarter and check. Okay, on the bottom it says 44 equals 44. Yes, it does. So this one's 0. And if my bottom symbol is 0, then the letter I use is neutron. So I'm going to circle that one as my radioactive particle and write neutron. This is potassium 40. Potassium 40 breaks up into, you beta believe this is the weird one. So I'm going to circle it and write beta. Okay. Now I need a little warning siren going off in my brain telling me this is going to be the harder one that I'm more likely to miss on the test. because it's the weird one. 40 mass breaks up into 0. Nothing's going to break off. So my top number is going to stay 40. My total number of protons and neutrons. My bottom number, this says 19 equals -1 plus something. So 19 equals -1 plus x. So the opposite of plus -1 is +1, so 20. Okay, that's difficult. Let's try looking at it this way. 20 take away 1 equals 19. Yes. -1 plus 20, if you even want to do that. Ready? -1 plus 20 equals 19. So check your work. Number 20 is calcium, so my symbol is going to be Ca. Okay, you beta believe that's our weird one. Uh-oh, number 9. Again, you beta believe this is a weird one. I'm going to call that a beta particle. And then I'm going to put a star by it on my test that says go slow, check your work, be careful. The top number is going to stay 30. It says aluminum 30 breaks up into 30. So 30 equals 30. Yes, it does. Plus 0. Okay. 13 equals something plus -1. So something take away 1 is 13. 12 take away 1 would be 11, so it's not 12. 14 take away 1 is 13. So I'm going to say 14 here. And on my periodic table, number 14 is silicon, Si. So big S, lowercase I, silicon. Okay, come in for some extra help if you feel like you need it. Good job.